Okay guys, could you hear me and see me? I think you could hear me, but now could you see me? Could you see my screen actually? Okay, just a minute. Just a minute. Okay, so let's get started. Uh, today I think that's the day we are going to end our introductory to the programming, introductory content for the programming. Actually, we were demonstrating about the topics of programming primitives and basics. Okay. In this session, I'm going to use our last notes folder, notes file. Okay. Okay. We are going to continue what we were demonstrating. We are going to start with something called structures. So now we are going to explain what structures are. Okay. So let's get started with the structures. I have prepared some examples here for you. Okay, so that's it. This is our first example here. Okay, so that's it. Yes. Okay. So now, what is a structure actually? Okay. A structure is something like you are making or you are defining a new variable type. You are going to define a new variable scheme actually. So you could use it within your code or your program in a way that you certainly know what you are going to do. Okay. So let's take something like this. This is a structure or a C structure or C struct. Okay, you can call it what you want. Okay, you are going to write something like this. You are going to write the word struct here. Then this is the name of the structure you are going to make. Then you are going to open these two brackets here and use the semicolon, and then you are going to declare or you are going to mention some definitions of some variables, some inner variables for this structure. Okay, so this is could be called a scheme for the structure. This is the scheme how the structure is organized actually. Okay, so here I have made two variables. One, the first is called x and the second is called y. So these are the variables I would like to use when I'm going to make variables of this type of structures. Okay, the structure that's called point here. Okay, so now when I'm going to actually declare a structure like this line here, I'm going to declare it using this syntax here. I'm going to write struct point, that's the name of the structure. Then this is the name of the variable here. This is the name of the new variable I have created. So now this variable actually contains two inner variables. This contains two inner variables here, as I see. One is called x, which is a member of this variable point one, and the other is called y, which is a member also of the same variable of structure. Okay, you see this. This structure represents a point in a plane actually that has two coordinates or two coordinate values x and y. Okay, so now I'm going to deal with this. So now I need a single variable that contains the information x and y actually, about a single point within a plane. Okay, so now I have created a variable called point1, which is of type struct point. Okay, then I'm going to assign 6 to the x of point1 and 10 to y of point1 also. So this is the syntax that I could use when I'm going to deal with a structure I have declared here. I have declared a structure called or a variable of the structure that's called point1. Then I'm going to assign the right values for its inner members. Okay, so this is one way of doing this actually. So here actually I'm going to remove all of these now. I wouldn't use any of these at the moment. So here I'm going to print what is inside this point1 here. I'm going to print the x of point1 and y of point1 using this format. Okay, so let's try this. So this is our result here. I have point1 x equals 6 and point1 y equals 10. So that's it. Okay. Okay, there is another way to declare to define a point like this. Okay, so let's copy these two lines from here. Okay, now you see another way to declare a variable and define it. Okay, you see here that I have written a struct point. Then this variable this time is called point2, and now it has 7 and 11 for its two inner members x and y. Okay, so here this syntax is valid for this purpose actually, but you should take care of the order actually. So the first one here after the bracket is assigned to x actually, and the second one here, which is has the order number 2 or the second order, is for the y variable actually. It's assigned to y. Okay, and here I'm going to print the same line actually. So let's try this, and it's true. Okay, now point2 x is 7 and point2 y is 11. Okay, let's see the third way of defining this. Okay, the syntax actually is preferred for me, or is preferred by me. Okay, I have here another variable that's called point3. Okay, that's of the type of struct point. Okay, so now I could deal with it. I have defined the values of x and y in this way. Okay, so this syntax also is valid here. I'm going to write something like dot, okay, x. Okay, so this dot x axis yeah, okay, guarantees the access of the inner variable or the inner member x. Okay, which is equal to whatever it was equal to, like 8, and this is the other member, which is y. Now it's equal to 15. You see here I'm using this colon, okay, to separate between them. Actually this syntax doesn't require that you define these in the same order. Okay, so I'm going to run this actually, and it's right. We have 8 and 15 here. Now I'm going to reverse these, like y here and x here. Then this is 15 and this is 8. So let's try this. Okay, I have a problem here, I think. Okay, actually it needs the order, okay. I think it needs the order actually, but some compilers accept this manner actually. It's new for me, okay. So I think I have made something that may be odd to this compiler, but some compilers, some copies or editions of compilers accept no orders. But okay, let's keep the order. I'm mistaken at this assumption actually. So now it is more clear actually, okay. This way is more clear than the two others. But I think here I could remove one of them and it would accept it actually. Yes, it's accepted here, okay. You could when you want to only assign some values to some certain inner variables or some certain inner members, but the others are not required at the moment, okay. You could only assign to these required inner members, but leave the others unassigned, okay. So I have made this here and it's accepted actually by the compiler, okay. So that's it, you see, okay. So now, do you have any questions? Anyone have a question or something? Go and raise your hand actually. Okay, I think I have. Will this class be available to rewatch? Is there a record? I think it would be recorded actually. Now I record this class actually, but some technical issues might happen, so I couldn't assume it would be 100% recorded. So I'm doing my best, but I think it would be available after this time. By you could revisit our YouTube list, our YouTube video playlist, okay. Then you are going to find this session recorded after we finish, okay. Okay, anyone else? Okay, no one has a question or something. Okay, let's get back here to our example. Okay, now I want to explain something actually. Okay, what is the size in memory for the structure, okay. Now I think I have told you about the size of function or size of operator within C++ and C, okay. So here I'm going to print the size of the integer variable actually, okay. So size of integer is equal to this size, okay, in bytes actually, in bytes, okay. Then I'm going to print the size of the type, the new type I have created actually, which is struct point, okay. So I'm going to print these two numbers here, okay, in bytes actually. So let's try this. So now here we have the size of an integer is 4 bytes only, but the size of the struct point is 8 bytes, and it is logically true, okay, because we have here the point that has two integers here, x and y, and each one has 4 bytes. So now a point has 8 bytes, so it's true, okay. It's true in this case, okay. So you see how storage is going to be done with structures here, okay. So this could be helpful at some time. Okay, you are welcome, Zainab, you are welcome. Okay, let's get back to our session. I have here demonstrated and worked with the structures. Now I'm going to a new thing, okay. Okay, let's save it, and let's go to a new thing here in session 5. Now I'm going to create our notes file for this. Okay, let's start. Now we are going to talk about something called functions. Okay, then we are going to talk about something called the preprocessor. And actually this preprocessor is going to explain, but not totally. Okay, we are going to explain something called hash include. We are going to talk about something called hash define. I'm sorry for this. Then we are going to talk about something called hash if not defined. Okay, if and if not defined. Okay, after that I'm going to talk about something some notes, actually some additional notes for you, and if we have time, I think we are going to solve a simple problem to make an example for this. Okay, so let's start by functions. Okay, I have prepared an example for you, but I'm going back to our first session. Sorry, the second session actually, or it may be yes, here's second session. Remember when we were talking about a calculator example? We were talking about the if condition, actually the conditional if. Okay, okay, you remember this example here? Okay, this was an example of a calculator. Actually, we were using some numbers and an operator, two numbers and an operator, in order to achieve a result, something like this. When I'm going to write 4 and 3, then plus, then I'm getting 7, the result is 7. Okay, actually when I'm going to write something like 7 and 10, then multiplication, then the result is 70. Okay, so that's it. I'm going to edit this example here to talk about something called a function. Okay, what's a function in C or C++? A function is a piece of code that has three information, actually three points of information, like this. I'm going here to make something called add, a new function, something called function, that I'm going to name it as add. Okay, something like this: integer add integer x, sorry, integer y, and this is called a function, actually. Okay, you see, so this is a function. Okay, it could be defined by three points of information, actually. This is the first one, and this is the second one, and these are the third type of information I would like to talk about. Okay, so here let's start with this. Actually, this is its name. Okay, so this is its name, actually. Its name is add, so this is its name, and the second one is its return type. Okay, it returns a result which has the type of integer, actually, and in order to return this result, it should have two inputs here, which are defined here. The first is called x and the second is called y, and both inputs are integers. Okay, so here I could write it as the return type, its name. Okay, then here its inputs with types. Okay, so this is how you could define a function like this. Okay, I have replaced this with integer, it returns integer, a variable in integer actually, or a value in integer, okay? And this is called add, and these inputs are x and y, and both here are integers, okay? You see, this is what I have done here, okay? So this is a function. Now you are going to ask what are these brackets about, okay? So here you are going to write a piece of code. You are going to write a piece of code that represents the operation of this function here, okay? So this function contains some code that is going to be like reused within many places in your code, or it could be repeated within many places in your code. So you are going to write your code in a single place and reuse it in a more simple way, actually, like I'm going to tell you here. Okay, I want to say something that in functions like this, okay, there is an important keyword in C and C++. Okay, you have a keyword that's called return. What this keyword is responsible for, okay, it is responsible for obtaining the result expected by this function, okay? This function is expected to return an integer value, and the return keyword returns this value actually. So here I'm going to return something like a value or a result or something obtained by this function. Here in our case, this function makes the addition operation, so it returns the addition of x plus y. So that's it. You see, it's very simple. I have made the summation, okay, of x and y, and returned its value, its new value, okay? So this is the result here. I'm going to return it back, okay? So let's try something like this. Actually, it's very simple here. Do you remember our example here? You have a, b, and c, and we have another variable that's called operator here, okay? So I'm going to ask the user to input these two variables, the first operand and the second operand, then our operator, okay, which defines our operation here, okay? So now if our operator is plus, I'm going to get the result in the variable c, which is equal to a plus b, okay? I'm going to edit something here, a little something. I'm going to, let's try something like this. I'm going to remove all of these, okay? Then I'm going to write add, okay, a and b. Please, I'm going to tell my computer, or I'm going to tell my program, please add the two variables a and b for me and get the result. So now the result is going to be returned by this statement return, okay, and it's going to be assigned here to the variable c. So let's try this. Now 2 and 3 and the plus, we have our 5. We have the result as 5 here. You see what happens if I wanted to make many additions like this in my code? So I could simply use this function, okay? Imagine that you have an operation that is more complicated than just addition, than just this plus here, okay? Imagine that you have some kind of making some calculations here. You are going to make something like some calculations here, then something like optimization or something, then something like sorting here, and after that you are going to return the result, okay? So these are many operations. You are going to put these here within these two brackets of your function, and you are going to call your function at any place you want to use it. This is called function call. This is a function call. Okay, I have called the function that's called add here. Okay, and I have passed, this is passing, I have passed a and b to the function, then I'm going to get the result back. Okay, you see, so this is an example of it. Now anyone has a question or something, go and raise your hand, and I'm going to answer your questions. Okay, no questions here. Okay, let's complete our example here. I'm going to make something called subtract. Okay, and I'm returning the subtraction here. I think I could use my my example here to facilitate the copy and paste. Actually, I had here subtract and multiply. I'm going to copy these here. Okay, so here I have also multiply and divide. Okay, here multiplication and here division. Okay, also you could remove these brackets, these round brackets could be removed here. The syntax is right also. Okay, they are not required actually. It's a very simple operation. It's not required that you could think that you need two brackets here, two round brackets actually. Okay, so now I have four functions. I have the add function, I have the subtract function, I have the multiply function, and also I have the divide function. I have the four functions here. Okay, I'm going to use them within my code actually. So here I have C is equal to A minus B, so I'm going to use subtract, okay, A and B. Okay, now I'm going here to use multiply. So that's multiply here with A and B. Now I'm going to use divide. Okay, using A, I'm passing the variable A, this is passed to the function, and B. Okay, so these are function calls. Okay, and these are the variable passed to the function, and the variable is going to return a result to the variable C here in our case, and I'm going to print the variable C on my screen. Okay, so let's try this. Okay, so that's it. I have 4 and 3 plus, it's 7. I have 2 and 1 and minus, I have 1. Now I have something like 3 and 3, then multiplication, so that's 9. I have 5, sorry, 10 and 5, then division, so I have 2. So I'm right here. Okay, so all of these are called functions. This is a function, this is a function, and also these are two functions. I would like to talk about something that's very important also. Okay, when you have functions that this function doesn't return anything. Okay, something like a function that prints a word on the screen or something. Okay, I mean something like this. I'm going to write something like my print, okay, or something like print number. I'm going to make a function that's called print number. Okay, and I could supply an integer to this function, an integer. Okay, like x or something, and this function, all it does is printing something like your number is, okay, then this x, then a new line, and that's it. Okay, this function doesn't return anything. I didn't write the word return here. Okay, there is no return. Okay, so how I could write here, right here in this place, it's return type. Okay, there is no type, there is no returning. Okay, so here I could write something that's called void. Okay, so here I have void. Okay, this function returns void. Void here means nothing. I have a function that returns nothing. Okay, so this void is nothing. Okay, and this function is called the print number, at it returns nothing. Then I'm going to call it here print number, anything, 6 or any. Okay, then I'm going to run this. So here I have my function executed here with passing the number 6, and it's printed on my screen here. It's right. Okay, so now anyone have a question, go and raise your hand. I'm waiting for you. Okay, Omar, go on.
For the calculation example, can we collect all the possible calculations for two numbers in one call? I mean that we can collect it in an array and return the array.
So sorry, I couldn't get it.
I mean that I want to collect the addition, multiplication, subtraction, all in one array and return from the function.
Okay, you mean you need to do something like this. Integer, calculate. Okay, integer x, integer y, then enter operator or something. Let's make it OB for now. You mean you need to do something like this?
Yes, and do some calculations like addition and subtraction, and return the two results in an array, as I think in C language it is one variable, it is returned.
Yes. What are the two results actually you want to return?
Addition and subtraction.
No. Here I wanted also to yes, I know what you mean. Okay, but here I want to make a single operation here, but you could achieve this. Okay, using many ways, but I'm not going to explain this right now. But it's really interesting to search about something like using functions with arrays as arguments or parameters. Okay, and you are going to see some tutorials here like this one. Okay, you are going to find how you could do this. Actually, you will learn that an array is actually treated here like a pointer, something called pointer. Then you are going, or something like this. Actually, this is valid also here. Okay, in this case, I think I have a problem with my device actually. Okay, that's it, and so on. Okay, so you are right. Actually, you could return what you you want to return an array on something, but also you could return your result in a pointer, something that's called a pointer. You are going to search for using like this, using pointers with functions. So that's true also. Okay, see buses, addresses, and the pointers to function like this. Okay, see this is also valid. Okay, I want to say something. Actually, I have remembered this. These inputs are called arguments. These are the parameters or the arguments of the function. Okay, so these are called arguments. Okay. Okay. I think I have answered your question.
Exactly. Thank you.
Welcome. Okay, now I'm going to the next topic. I'm going to explain something called the preprocessor. Okay, it's very easy, but somehow tricky. Okay. So let's get back here. And now we are going to the preprocessor here. Okay, so I'm going to clean this here actually, and this also. Okay, so that's it. And now I have my preprocessor. Okay, so let's start. The preprocessor has three things here I'm going to explain or talk about. The first one is called hash include. Okay, that includes some files or some libraries that are needed within my code. Actually, you are using this here. Okay, something like this. Hash include. Okay, IEEEXtreme. Okay, firstly I would like to say something that I have forgotten to say, that a preprocessor is a software part within your compiler. Actually, we are compiling our code here, okay, using a certain compiler. Actually, our compiler here is called GCC. Okay, GCC, and the or G++ for C++. Okay, G++. G is for GNU. It is part of GNU tools that are made, I think, within 18s actually. GNU C compiler and the GNU++ are kinds of compilers for C and C++ that are made by the GNU. Okay, the GNU tools or the GNU foundation for software. Okay, now I want to say something, that your compiler actually has a certain part that's called the preprocessor. This preprocessor is going to navigate to all your files, to all your software files that are written in C++ or C. Actually, here we have only one file. Okay, that's called main cpp, main.cpp. It's our file that's written in C++. Your compiler has a preprocessor that's going to navigate to your file that's main.cpp here. Actually, I am opening here in my IDE. Okay, then it's going to make some edits to this file. This preprocessor always searches for this hash. Okay, it searches for this hash, hash character. Okay, it's going to search for this hash and is going to interpret what is going to be written here. So now here I have written something called hash include, then a certain word here that's IEEEXtreme in our case. Okay, so here I'm going to include my IEEEXtreme, or actually I'm going to include the IEEEXtreme library, the IEEEXtreme file, the file of IEEEXtreme, the header file, something called the header file. I'm going to include the header file of IEEEXtreme in my code here. So the preprocessor is going to interpret this hash include and searches for IOStream, and then it gets its contents here. The contents of IOStream is going to be replaced and is going to be substituted here, okay, within my file. Then the preprocessor is going to incrementally search for its directives. Actually, each hash here is called the directive. This is a hash include directive, okay? So this is firstly our hash include and how it works actually, okay? I mean here I have written the name of the file I needed for my code, that's IOStream, and also I could make some files here within my program or my project here, or my project in my IDE, okay? And here I'm going to use this kind of brackets. I'm going to use double quotation marks here like this, dot h, okay? So I'm going here to add a new file, okay? I'm going to add a new file here, add files here or something, okay, to my project, and I'm going to name it in this way, and I'm going to include it in my project if I need it with these double quotation marks here. I'm not going to use this brackets, these brackets or these kind of brackets, triangular brackets here. I'm not going to use these, okay? I'm going to use these double quotation marks, okay? So this is the difference here, okay? So now I have my IOStream that's needed for my code, so that's the hash include actually. Okay, now I'm going to talk about the hash define. I have prepared it here in my example for you. So this is a hash define here, okay. Here I'm going to tell my preprocessor, that's a part of my compiler, that I have a symbol. I have made a symbol that's called by constant, okay. I have made a symbol that's called by constant, and I'm telling my preprocessor to substitute any existence of this symbol with this substitution, which is 3.14, okay. So this is our by constant here definition. Now I'm going to use this in my code like this, actually something like this here. I'm going to print this constant on my screen here, okay. So now the preprocessor is going to navigate to my file, and it incrementally views its directives here. It's going to replace this directive with the contents of the file that's called IOStream. Then the preprocessor is going to see this hash defined by constant with 3.14. So it's going to incrementally search the file, and it searches for this symbol. Actually it finds this symbol here, and it's going to replace it with its replacement here, that is 3.14, okay. So this is a preprocessor. Now the compiler continues his work, its work actually, using the new form of my file, okay. So that's it. So let's try this here. I'm going to print this. Now I have 3.14 on my screen. What happens when I'm going to change this? I'm going to search about the by constant, its actual value actually, okay. Yes, this is its actual value here. So what happens to my code when I'm going to change this, okay, to something like this? I have added these 3 digits here. I'm going to compile it and run it, okay. So I have the new result on my screen. So this is done by the preprocessor. The preprocessor has substituted this with its replacement here, this, you see. So this is the work of this hash define actually, okay. There is another example to this hash define here, okay, that's called macros, or or macro functions. I'm going to explain about this. I have two lines here. I could explain this here. Okay. Okay. This is called macro or macro function. Okay. That's also right. Okay. Now I have this line. I want to copy this also. Okay, so that's it. Okay, let's see what happens here. Okay, so this is a macro or macro function. Okay, the preprocessor is going to deal with how. Actually, I have called this macro as add. Then I'm going to supply something like two parameters also. Okay, the first I have called it x, the second I have called it y, and its expansion or its substitution is this word. So here my preprocessor is going to search about it. Actually, it finds this here. Okay, like I'm going to say add 2 and 3. Okay, so now my preprocessor is going to remove this. I would like to copy this here. Okay, my preprocessor is going to remove this, remove all of this like this, and it's going to substitute it with this. Okay, and the values I have supplied for x and y were 2 and 3. Also, the preprocessor is going to replace this. Okay, it's going to be to replace this itself. Okay, so now I have something like this. Now the compiler continues its work, and this is going to be compiled completely. And when I'm going to run this, I have the execution of this code here. Okay, so let's try this and let's have a discussion about it. So let's run this actually. So now I have 5 printed on my screen, which is right. Okay, so now someone could ask me, what is the difference between this, okay, and something like integer add integer x integer y return x plus y. Okay, so I'm going to say some differences between this and this. Okay, actually this is going to be substituted by the preprocessor before continuing the compilation process of this code. Okay, so this is a text replacement here. You are going to replace this with 2 plus 3. But here, for this, okay, this is going to be compiled and this is going to be executed when I'm going to run my program. So that's the first difference actually. The second difference, okay, is that here, and this is a text replacement, so I didn't supply any details about the types of these. I didn't say that this is integer or float or something. Okay, this is going to be replaced here. Okay, so the preprocessor and also the next phase of the compilation are not going to check about these. Okay, but here in this function, these are going to be checked actually, and if they are not of the same type, the compiler is going to print some warning message for me in order to take care of this. So this is a very big difference here. So now you have all of these checks are not going to be made. Are not going to be made here, but they are going to be satisfied here. Okay, so this is the second difference. Actually, there is a third difference. Okay, this is going to take a storage within your code. Okay, I mean your code when it's compiled actually. Okay, you have a new file, you have a new runnable file. Okay, you have a new executable file. So this is going to take some of its size actually, but this is going to take nothing. Okay, because it is only text replacement, but it's not going to be compiled here. It's not going to be converted into zeros and ones. It's not going to be converted into machine code, or a machine or a code that the machine could understand. Okay, so these are the three differences. You are going to use this when you need, and you are going to use this when you need. Okay, you are going to use this when you see it is safe, and you could achieve something you need, and you are going to use the other way if you are going to see that it is really required. You require that you need these checks here, and there is no problem with the program size of yourself, and so on. Okay, so these are the two differences here. Okay, I mean, do anyone have a question or something? Okay, now I think after I think 10 minutes from now, I think the meeting is going to be restarted. Okay, the meeting is going to be restarted because of some new limitations on Microsoft Teams. Okay, so when we face this, we are going to take 5 minutes for a break. Okay, then we are going to continue. Okay, now I'm going to continue. I have another example for this, like this. Okay, I have made this for you. Someone could ask me how I could make benefit of this macro expansion here, or macro definition. So I'm going to, okay, let's write this ourselves here. Okay, look at this. This is also a macro I have defined here. I have called this loop. Okay, and I have replaced this with the first line, the first known line of our famous for loop. Okay, so I want to say something here for you, that the for loop could be written like this: for integer counter which is equal to 0. Then I want to finish this loop when my counter exceeds the number 10. So I'm going to compare it to 11. Then I'm going to write something like counter plus plus. Then I'm going to print this on my screen here. Okay, see out counter. Okay, I want to add something I think we didn't talk about. Okay, actually when we have explained this, I think I have written this here. Okay, I have written this here, and then I have written counter which is equal to 0 here, which initialization. Then I remember I have written counter which is equal to counter plus 1. Okay, so this is the increment statement, or the increment phrase that's going to be executed after each repetition. Okay, and actually it works here. It prints from 0 to 10. But the new thing I'm going to talk about, that you could declare your variable here. You could declare and define, both declare and define your variable here. Okay, you could write this here totally. Okay, and also you could replace this with our increment operator. You remember our post and the pre increment operator, any one of these. You could use plus plus here, or plus plus here. These are two valid expressions here actually. But for your information, this is more optimized for the preprocessor. Sorry, this is more optimized for your machine, for your processor, for your device to execute. Okay, so let's execute this. Okay, and the same result appears here, and actually it is the same result actually here. You see, so you could write your for loop this way. Okay, okay, now I'm going back to my preprocessor here. Okay, hash define loop. It takes it takes four parameters actually, or four arguments. The first one I have called it type. The second one I have called it var, which means variable. Okay, the next one is going to be start. The next one is going to be end. What is this? I have written for, then I have declared the variable here. Okay, I have used the type I have supplied here, I have passed here. Then this is the name of my counter variable here, which is going to start from this value. Okay, let's get back. Okay, so now we were talking about this hash define here. Okay, I have made something called loop actually. Okay, that's right. Okay, I have supplied four parameters or four arguments here. The first one is called type, the second one is called the variable, the third one is the start, and the next one is the end. Okay, now I have made its replacement, its text replacement actually, as the first line of any for loop we are going to use. Okay, like this. I have written for, then I have declared here my variable. Okay, using the supplied type and the variable name. Okay, with its start here. Okay, from these parameters here. Actually it's like this. Okay, like this exactly. Okay, and I have made my ending condition here. I have made my condition here. Okay, which is that variable is going to be less than the end. Okay, then this is the increment. Okay, statement. So this is like this actually. How could I use this? I could write something like loop. Okay, integer, then counter, then my start here is 0, then my end here is 11 actually. Okay, you see, so this, okay, is like this. So instead of writing this like many words and many characters, I'm going to write this simple line here. Okay, and I'm going to remove this, and let's run this. Okay, so I'm going to get the same result here. Okay, so I'm right. Okay, so the B processor could help you achieving something like this. Okay, actually this is called a macro. Okay, and it's commonly known as a helper macro. Okay, this is a helper macro that is going to accelerate your writing experience here. Okay, so that's it. Now I'm going to talk about, I think, the last thing of the preprocessor topic. I'm going to talk about this f not defined, hash f not defined. Okay, I'm going to explain this using these lines like this. Okay, I'm going to remove all of these actually. Okay, so that's it. Okay, okay, let's try to explain this actually, how this is going to work. Okay, I'm going to write something like hash if not defined. Okay, then I'm going to ask if a certain symbol here is not defined. I have called it print hello for now. Okay, so this is something called the pre-processing or conditional pre-processing. Okay, this is a conditional pre-processing. This directive is conditional for the pre-processor. Okay, then I'm going to write something like else here. Okay, and this is its syntax. Okay, actually I want to use this. Okay, so these are its three main parts. Okay, I could remove this, I could remove this else. Okay, but you must write, actually this is not written like this, it's written like this. Okay, I'm sorry. You must supply this end f. Okay, each if not defined, or actually there are more directives like these. Okay, there are more directives like this if not defined. There is if defined, there is if hash if, and there are some directives like this for conditional pre-processing, but I am stressing or on this if not defined actually for a purpose I'm going to talk about after a while. Okay, so here I'm going to write some symbol here, some preprocessor symbol like hash define. I have made definition of something using hash define, then I'm going to use its symbol here. Then I could write some code here or pre-processing directives. Okay, I could write what I want here. Okay, and also I could write what I want here or any. Okay, so this is how to use if not defined, and the preprocessor is going to search for this symbol. Okay, if it couldn't find the symbol within the files used for the compilation, okay, then it's going to add these lines of code. Okay, but if this is going to be defined, okay, these lines of code are going to be ignored and these lines of code are going to be added. Let's use this piece of code here to explain this. Okay, here I'm going to use two statements. This is cout statement that prints goodbye on the screen. Okay, and this is another statement that prints hello on the screen. Okay, this prints hello and this prints goodbye. Okay, so here I'm going to say that if print hello is not defined, so please print goodbye for me. Okay, but if this print hello is defined, please print hello for me. Okay, so here I'm going to say that I'm going to define print hello here with no replacements. Okay, so now you see this is highlighted and this is not highlighted anymore. Okay, so if print hello is defined anywhere, okay, before this actually, okay, before this piece of code, okay, so hello is going to be printed on the screen. Let's try this. I have hello printed on my screen, but what happens if I have removed this? Okay, so let's run this. I have goodbye printed on my screen. So this is one directive for conditional pre-processing. Okay, I could use here. What happens if I have defined this here after this piece of code? Okay, so nothing happens actually. Okay, goodbye is printed, so it has to be written here. Okay, so now hello is printed instead. Okay, you see, so this is conditional pre-processing, okay, using if not defined. So we have finished all of this. So now any questions? Okay, I see no hands raised right now, so let's continue. Okay, we have a section for some additional notes I'm going to talk about. Okay, go on Zainab, go on.
Hi, I don't really understand the differences between processors and the if and statements and the function statements.
You don't see the difference between this and the original if like this? That's your question?
Yes.
Okay. I'm going to tell you what's the difference actually. Okay. let's try making something like this. I'm going to write something like a simple while loop here, okay, and I'm going to use a variable that's called counter, okay, and I'm going to make counter plus plus, okay, and I'm going to declare my counter here and assign 0 to this, so it's defined as a 0 assigned to counter. Okay, now I'm going to see out counter with new line, okay, but I'm going to set a condition here if counter is greater than 5 or something, or 4, let's make it 4, okay, so please print its value on the screen, but else print something else like cout not ready or something like that. I mean, my value is not ready for another operation or something, okay. So this is really simple. When I'm going to run this, okay, I have this, okay, let's try this, okay. So now I have not ready printed for 6 times or 5 times actually. Then I have the rest of the numbers printed on my screen, okay. So this is executed after it has been compiled, okay, within my code. But what happens if I have used something like hash f, okay, counter sorry, greater than 4 or something, okay, in this way, and I have removed all of these, and I have used hash else, okay, and I have used hash and f. Okay, so now that's it. Okay, let's try to run this. Okay, actually it has printed not ready, and it's not right. It's not a right logic for us. Okay, what happened here? Okay, actually these are this hash f and hash else and hash end f, they are part of the preprocessor. They are not part of the core compilation process, okay. So they are going to be executed, okay, they are going to be to have its action before the end of the compilation process, okay. So now this line, okay, is not going to be included in our code. This line is going to be included instead, okay, on this part of our code for all of the values, okay. This is not going to work. Why is this not going to work? Because the preprocessor doesn't know about this variable, okay. It's not mentioned within the preprocessor system. I didn't define this, okay. And also the variable counter is going to be incremented here, okay. This is not going to be known for the preprocessor. The preprocessor doesn't know that this counter is going to be incremented here. So there is a kind of unknown behavior. There is a kind of unknown behavior that happened here, from the preprocessor. The preprocessor has included this statement instead. Okay, this is not defined actually. You don't know really if the preprocessor is going to consider this or this. Okay, so this is a work of the preprocessor. Okay, and our original if is a work of our compiler. Actually, the preprocessor is a stage before compilation. Okay, so our logic here is going to be executed as we wanted, as we require. Okay, I've answered your question.
Yes, thank you.
You are welcome. You are welcome. Okay. Let's get back to our content. We have some additional notes for your problem solving or your competitive programming. Okay. So let's get back to our folder here. I don't want this anymore, but I want this. Okay. Some additional notes here. So let's take a look at this. Okay. So now I want to add, maybe it's a new information for you. Actually, that you have cout that prints, okay, anything on your screen or something. Okay, I'm going to print hello or something on my screen. Then I'm going to, you could remove this script character, this \n. You could remove this, and you could write something like endl. What's endl? Endl is an abbreviation for end line. Okay, and also it adds new line to your screen. Okay, so let's try to make something more readable here for us. I think this is going to work. Okay, you see this? Okay, you see good and buy are printed in two lines because of this end line here. Okay, what happens if we have used this \n as we are going to use? It's also the same. Okay, so what's the difference here? Actually, the new thing I want to say, that end line, this endl is famous when using cout statements. Okay, and you could use it in order to print new lines also on the screen, like you use your \n, your script character \n. So these are the same for now. Okay, but there is another difference, that end line here works with cout in a certain way. I would like to say that all you are going to print on your screen, okay, is going to be stored within a buffer. There is a buffer in your system, in your program that's created by this cout. Okay, and when you finish the execution of cout, all its contents are going to be printed on the screen. But endline makes an additional behavior for this. Okay, it making something like flushing. It flushes your buffer, the buffer that's going to be printed on the screen at the moment. So this endline flushes the buffer here, and the code is going to be printed. Then by is going to be printed after that, after the second time of flushing. Okay, so sometimes when you are using end line in this way, you are going to make something like an additional effort for flushing. When you are going to use this like this, and print, sorry, end line, and print anything here, then another line, and so on. You are going to make the flush operation many times, okay? But what happens when you use our traditional \n here? This flushing operation is going to be done once, okay? You are not going to make some more additional overhead to your processor, okay? So this is better actually here when you are going to execute your code. So there is this is a note for you, and also you could make these things more simple by hash define end line as \n, and that's it. You also could define it as a single character, but I'm not going to explain this in deep here, okay? So you are going to write this actually, okay? But this is going to be a single character, okay? It's like I think I have explained this for you before. Like you are going to make something like car my character, and you are going to assign a for it, okay? So when you are going to print this my character here, you are going to print a on the screen, okay? It's the character a, like the one in your keyboard actually. This is the same here, okay? So these are both are right, okay? So this is the first note for the end line, okay? So I think I have written this here, yes. This makes the cout faster for you, okay? But I prefer using the single character. I think there are no more overhead using a single character actually, okay? So this makes your cout faster, okay? This is the first note. The second note is going to be relative to our cn, okay? So let's try this, okay? These two lines makes your cn faster, okay? Actually this is a function that's member of the cn, and this is another function that's member of the cn also. You are going to use these lines as they are, okay? How this works actually, okay? These two lines makes a link between the implementation of the statement or the word cn and the other word that's scanf. Do you remember scanf? Scanf, okay? I have used this scanf to get input from the user. Actually, in the first session, I have used scanf and cn. I have explained both keywords, okay? Or both statements, both input statements, okay? I have explained these both for you. Actually, the implementation of scanf is more faster than the implementation of cn, okay? So these two lines makes the link, the needed link, and the needed synchronization here with the implementation of scanf. So now cn is faster as scanf, okay? So this also makes your cn faster, and it helps you in the execution time that's required actually for your problems when you solve problems in an online judge or something, okay? So this could help you also, okay? So now we could use cin more faster. So I have made cin faster and I have made cout faster actually. Also there is another additional note here. Okay, you could use an input file for testing. So what is this about? You see here I have used a conditional pre-processing actually. If not defined online judge, make something called file reopen. This is an abbreviation for file reopen. Okay, file reopen. Okay, I have made a new file that's called input.txt. I would like to show you after a while, and I'm going to read some input from this file as I'm reading from my standard input. Okay, the standard input is actually the input you are going to take from the keyboard. So I'm going to replace my standard input from my keyboard to this file. I'm going to show you now, okay, how this could be achieved actually. Let's go and search about Vanya and the fence. Okay. So I have shared this problem with you before. Okay. This is called Code Forces, and this is an online judge to solve problems in, and this is one problem that could be solved with programming or code. Okay. So now you are going to have some input and you are required to make the right output for this set of inputs. Okay. Actually, I want to explain this problem for you, and you are going to solve it right now. I hope we could solve it right now. In order to explain how this could be used, this could make your solving a problem easier. Okay, so let's try this. Actually, I would like to have something visual. Just a minute. Yes, that's it. Okay. Okay. What does this problem says actually? Okay. This problem says that there is a fence here. Okay. This is a fence here. Okay. And we have a guard that is sitting behind, this is behind this fence. Okay. And now we have some people, okay, that are going to pass here. They are going to walk here, and they want that this guard couldn't be able to see them. They want to hide from this guard. Okay. Okay. So we have some people here that could pass here. Okay. Some of them are short enough so the guard couldn't see them, and some of them are tall, very tall. They are very tall here. Okay. So the guard could notice them. Okay. So what is the solution for this? Actually this one, okay, could bend himself. He could bend himself, so he could go here, bent it like this, and he could pass here bent it, so the guard, this guard, couldn't notice any one of them. They are going to pass here, okay, in a row. They are going to pass in a row. They are going to pass. Each one is behind the other, okay? So now we need to calculate the length, okay, of this row. We need to calculate, this is a calculation, okay? This is a calculation problem. We need to calculate the length of this row. What is the length of this row, okay? How we could calculate this length? Actually, the standing person has the length of 1 meter, and the bent person has the length of 2 meters. How we could achieve this, okay? So now, I want to hide this, okay? The input is, the first line of the input contains 2 integers, okay? N and H, okay? What is N and what's H actually? N, the number of friends, okay? N is the number of friends, the number of the people they are going to pass this fence, okay? The number of these people actually, this is N, okay? And the height of the fence. What is the height of the fence? Okay, so H is the height. Actually, I'm going to use this color. What is the height of this fence? How long is this fence? Okay, in meters actually. So these are the first two numbers, N and H, like this, 3 and 7. So now we have 3 people, and our fence has 7 meters. Okay, okay. The second line contains n integers, okay, and each one is going to represent the ice of them is equal to the height of the ice person, which means the first one is tall as 4 meters, the second one is tall as 5 meters, the third one is tall as 14 meters. So now let's explain this from the beginning. Actually, I have cleared the screen right now. And now we have, like the first example says, actually, okay, we have this fence here, okay, with actually 7 meters, okay, and now we have 3 friends that are going to pass here in front of the fence, okay. The first one is short one, he is short guy here. Actually, he has the height of 4. The second one is taller, a little bit taller, okay, but this one has the height of 5, and the last one here, this one, has the height of 14 actually. This is a very tall guy, okay. He has the tall of 14, okay. So of course this guy actually is going to bend himself, okay. So now we have here 1 meter for this guy and 1 meter for this guy and 2 meters for this guy because he is going to bend himself actually. Then he is going to use this base of 2 meters. So now the total length of the row is going to be 4. This is the solution for the problem. Okay, 4 meters. So now we have 3 friends that are going to pass. The fence is going to be 7 meters tall, 7 meters as its height, okay? And the first person has the height of 4, the second is 5, the third is 14. Now we need the full length or the full width, actually, the valid width here of this row, okay? So now we have this, it occupies only 1 meter, and this occupies only 1 meter, and this occupies 2 meters. 1 plus 1 plus 2 is going to be 4. So that's it, okay? Okay, now what I'm going to talk about, these inputs are going to be supplied by hand, okay? So now let's try to solve the problem, the traditional way, then the new way, okay? Firstly, anyone doesn't get it? Anyone doesn't get the problem statement actually? If someone didn't get it, please go and raise your hand. Okay, very good, very, very good. Let's try to solve this actually. So I'm going to remove this for now. Then I'm going to make some variables. Integer n, okay. I have n and h, okay. Then I have some 3 variables here I could use. So I'm saying that I have, yes, the biggest number of the passing persons are going to be 1000. So let's try to create some sort of arrays here, like heights, arrays of heights, okay, or something. Okay, I'm going to use 1000 that are going to be defined or declared previously. Now I have n and h, okay, and that's it. Now I'm going to cn n and h, okay. Then I'm going to, I think I need to declare something called result or something, which is equal to 0 for now. Then let's try to make something like a for loop. Let's use our for loop we have made a minute ago. This, I'm going to use this. It's very easy. So here I'm going to make a loop to obtain my result. Integer counter, sorry, integer and the counter, and my start is from 0 and my end is up to n. Okay, then I'm going to cn heights of counter. I'm going to get the input from the user. Okay, then I could make something like if heights of counter is greater than h, then please result equals result plus 2, else result plus plus. Now I have finished, so let's see out result. So this is could be a solution. I'm going to check if it's true or not, if it is not, if it is right actually. Okay, so let's explain this. Okay, here I have declared two variables, n and h. I have here in my problem statement n and h, 3 and 7. Okay, in this case, so n and h, the number and the height of the fence. Okay, and the second line here I have declared a static array for it, which is called heights. Okay, I could declare this here actually. Okay, it's not mandatory to declare it outside here. Okay, so now I'm going to take the heights from the user. So I have heights of counter here. Okay, in a loop. Then I'm going to check if the height is greater than the fence height or not. Okay, if yes, please add to this result, which is 0, firstly 0, add 2 for it, and if not, please add 1 to it, then finish and print this result on the screen. Let's try this. Okay, I'm going to use, look, please pay attention for this. I'm going to write one by one here. Okay, so let's try this. I'm going to write 3, then 7. I'm going to write 4, 5, and 14. Okay, so I'm getting the right answer here, 4. Okay, I'm writing this by my hand actually. Okay, let's try the second one here. Okay, I have 6 and 1 and 6 ones actually. 1, 2, 3, 4, 5, 6. I have the right result. Okay, let's try the next one by hand. Okay, I have 6 and 5. Then I have 7, 6, 8, 9, 10, and 5. So yes, that's right. Actually, my code solves the problem in the right way. Okay, so now I'm going to submit this code, but actually I need to make something that helps me testing this more quick. Okay, okay, what is this? Actually, this is these two lines here. Okay, which means, please, if not online judge defined, please use the input of an input sorry, a text file I have made for you. Okay, how I could achieve this? Actually, I could achieve this using the project. Do you remember our project that made with the code blocks IDE? This IDE is called code blocks. Okay, I'm going to navigate to my project here. Okay, and I'm going to make a new file that's called input.txt, which is the same as the name mentioned here, input.txt. Okay, then I'm simply going to open it. Okay, and I'm going to copy these testing inputs. Okay, I'm going to click on this copy. Okay, then I'm going to paste it here, and I'm going to save it. Then I'm going to run this on this. So you see the result here is 4. It takes its input from this file now. You see, it takes its input from this file for now. Okay, let's try the second one. Copy. Okay, and then save it, and then run this. I have the right answer, 6, which is mentioned here. Okay, I have 6 here as this. Okay, now I'm going to copy this and put it this here, and I'm going to run this. I have 11, and I have 11 here actually. You see, I have 11 here, and I have 11 here. Okay, so that's right. So now it's more simple than writing each value by hand. If I have made hash define online judge here to make it work as previous, it's more simple than writing each one by hand. You see, this is more simple actually. Okay, so I'm going to remove this, and this is going to be more simple. I got the result at once. Okay, you see, so this could help you solve problems faster actually. This piece actually. So now I'm going to submit this solution actually, and it's going to run. Okay, because the online judge is going to make hash define of the word online judge. Some judges do this automatically. Okay, they are going to hash define online judge, and they are going to supply the server of the judging is going to supply these values. Okay, one by one, and this is going to be ignored. Okay, so I want to submit this actually. Just give me 1 minute. Okay, just give me 1 minute to log in.